Have you ever wondered if it's possible to catch fire in space? A curious question, isn't it? At first glance, the answer might seem an obvious no. After all, we've been taught that fire requires oxygen to burn, and space is famously known as a vacuum, devoid of oxygen. But what if I told you that this perception might not tell the entire story? That there's more to the relationship between fire and space than what meets the eye? Science, as we know, often challenges our common assumptions and presents us with new perspectives. And the behavior of fire in space is no exception. What if the flames could dance in the cosmos in ways we've never imagined? What if the cold, dark expanse of space isn't as hostile to fire as we believe? So let's dive deep into the world of fire and understand its behavior in space. Fire, as we know it, is a chemical reaction known as combustion. Let's dive into the fascinating science behind fire and combustion. At its core, fire is a testament to transformation, the conversion of potential energy into kinetic energy, light, and heat. This process is fueled by three crucial elements: fuel, oxygen, and heat, often referred to as the fire triangle. First up is fuel. Fuel is a substance that can undergo combustion. It can be a solid like wood or coal, a liquid like gasoline, or even a gas like propane. Fuel contains potential energy that's locked within its chemical bonds. When these bonds are broken, energy is released, and we see this as light and feel it as heat. Next is oxygen. Oxygen acts as an oxidizing agent, a substance that can accept electrons in a chemical reaction. It's the oxygen in our atmosphere that allows for the continuous burning of fuel. Without enough oxygen, a fire will smolder and die out. Lastly, we have heat, the catalyst that kickstarts the combustion process. Heat provides the energy required to increase the speed of the fuel molecules. When these molecules move fast enough, they can collide with oxygen, causing a chemical reaction that results in fire. Together, these three elements create the perfect conditions for a flame. Remove any one of them, and the fire goes out. This is how firefighters combat blazes, by removing one or more elements of the fire triangle. But here's an intriguing twist. Fire on Earth behaves differently from fire in space. Gravity affects the shape and color of flames. On Earth, the heated air around a fire rises, creating the familiar teardrop shape of a flame. But in the weightlessness of space, flames behave quite differently. Now that we understand the basics of fire, let's explore how these principles apply in the vacuum of space. Space, the final frontier, is vastly different from our earthly environment. This statement may seem like an obvious observation, but when it comes to fire, the differences are not as straightforward as one might think. In space, the usual rules we're accustomed to on Earth are turned on their heads. One of the most significant differences is the lack of oxygen. On Earth, oxygen is a key player in the combustion process. However, in the vacuum of space, there's no readily available supply of this crucial element. In fact, space is primarily filled with, well, space. It's an almost perfect vacuum with very few particles per cubic inch. This absence of oxygen means that fire as we know it can't exist in space. But that's not the only difference. The lack of gravity in space also has a profound effect on fire. On Earth, hot gases from a flame rise due to gravity pulling cooler, denser air downward. This convection process helps to feed the fire with fresh oxygen, allowing it to continue. In space, there's no up or down, no gravity to create this convection. Without gravity, hot gases don't rise, and a flame can't draw in fresh oxygen even if it were available. So what happens to the three elements necessary for fire: fuel, oxygen, and heat, in space? Fuel can be carried into space and heat can be generated, but as we've discussed, oxygen is a no-show. Without oxygen and the effects of gravity, fire behaves rather peculiarly in space. Instead of the familiar teardrop shape of a flame, fire in space forms a spherical shape. It burns at a lower temperature, and with a different color, often a faint blue, rather than the robust yellow-orange we're familiar with on Earth. So we see, fire in space doesn't behave as it does on Earth. But what does this mean for flames in the cosmos? Stay tuned as we unravel this mystery in our next segment. In the vacuum of space, without gravity to pull hot air up, fire behaves quite unusually. Let's take a moment to imagine a flame, not on Earth, but in the vast expanse of the cosmos. Without gravity, the hot air doesn't rise. There's no up for it to go to. Rather, it stays right where it is, surrounding the source of the fire. This results in a flame that, rather than flickering upwards like a dancer, forms a perfect, mesmerizing sphere. This spherical flame burns differently too. It's a bit of a cooler customer than its earthbound counterparts. See, on Earth, a flame's temperature can rise to around 2,000 degrees Fahrenheit at its core. However, in space, this spherical fire burns at a significantly lower temperature. Imagine a flame with all its fiery beauty, but with a cooler, less intense heat. Now, you might be wondering, how do we know all this? Well, we've done our homework. And by we, I mean the brilliant minds of scientists and astronauts who've conducted experiments in the great beyond. One such experiment was the Flame Extinguishment Experiment, or FLEX, conducted on the International Space Station. Here, astronauts observed how small droplets of fuel burned in microgravity. The results? The spherical flames we've just described. There was also the BASS experiment, or burning and suppression of solids, which studied how different materials burn in space. This experiment further confirmed the unique behavior of flames in microgravity, giving us valuable insights into how to handle potential fires in spacecrafts. So, what we have here is a completely different beast. A fire that doesn't dance upwards but forms a perfect sphere. A fire that burns cooler, yet is just as captivating. A fire that challenges our earthbound understanding of what a flame should be. These unique characteristics of space fire lead to some interesting implications. The behavior of fire in space has important implications, not just for astronauts, but for our understanding of chemical reactions. This isn't just an academic exercise. The nature of fire in the cosmos is a crucial consideration in the realms of astronaut safety, spacecraft design, and even the broader field of chemistry. Let's start with astronaut safety. In the confines of a spacecraft, fire can be a deadly hazard. Astronauts need to know how to prevent fires, how to extinguish them if they occur, and how to handle the aftermath. The peculiar behavior of fire in space, its tendency to smolder rather than flame, its formation of spherical shapes, requires specific strategies. Knowledge about fire in space helps astronauts and mission controllers on Earth to prepare for these emergencies. Beyond immediate safety, the behavior of fire in space also influences the design of spacecraft. Materials used in the construction of spacecraft must be chosen with care, taking into account how they will react to fire in a zero-gravity environment. The unique properties of fire in space could even inspire new materials and technologies. For instance, imagine a material that self-extinguishes in zero gravity by exploiting the spherical shape of spaceborne flames. Now let's shift gears and consider the broader scientific implications. The behavior of fire in space offers a unique window into chemical reactions. On Earth, the pull of gravity affects how gases mix and how heat disperses, influencing the course of chemical reactions. In space, without gravity's influence, we can observe these reactions in a whole new light. This could lead to new insights in chemistry, potentially sparking innovations in everything from energy production to environmental protection. Looking ahead, our understanding of fire in space could also be crucial for future space missions. Consider long-duration missions, like a journey to Mars. On such missions, the likelihood of a fire incident increases simply because of the extended time in space. Understanding fire in space will enable us to design safer spacecraft and develop better fire management strategies for these long voyages. Furthermore, as we plan for extraterrestrial colonies, we'll need to understand how to harness fire in these new environments. Could we use fire for heating, cooking, or disposal in a lunar or Martian habitat? What challenges would we face? Questions like these highlight the importance of our ongoing exploration of fire in space. So while it's not quite the same as catching fire on Earth, it is indeed possible to have fire in space. But remember, in the cosmos, even something as familiar as fire can behave in ways that defy our earthly expectations. So let's keep pushing the boundaries of knowledge, probing the mysteries of the universe, and challenging our perceptions. After all, the cosmos is full of surprises, and every discovery brings us one step closer to understanding our place in this vast expanse.